Alright, so we're discussing synchronization. We talked about the need for race conditions, or why race conditions occur, not the need for why they occur, why we need critical sections, testing solution to making sure that there is mutual exclusion, progress, and bounded weight. And we're going to discuss four concepts you've already seen in programming. Well, the first one I'm very sure everyone has seen, but the other two I'm not so sure. I'm going to start off with the idea of locks. Right? So the whole idea with a lock variable is usually there's some resource, maybe a buffer that you want to protect. So what you do is you would have a variable, maybe a buffer locker, right? Something that everyone must lock, and only one person can have the lock. It would be something like buffer lock, right? And maybe you could go to the buffer variable and maybe change something in there, right? Or in Java, someone may have something like uh, synchronized. Um, in Java, you have a synchronized keyword which you can use in a function. Say only one class instance can be running that code. So this is similar to say make sure that this is the locking, and at the end you unlock. So in Java, the lock and the unlock when you use synchronized is implicit, meaning only one person goes in there, has the lock, and when he leaves, he unsets the lock. Right. Now, in terms of programming, when we think of a lock, someone could write if lock, better written as while it is locked. So while someone has the lock, do nothing. So this is what I said was called busy waiting. Right. So the idea here for these lines is a process would indicate that it's interested in a lock. It would go and wait on the lock. So this is using busy waiting. And then when it finishes, maybe you could do some work with whatever it's supposed to work with. And finally releases the lock. You realize that a lot of times lock value is set to false, right? So when it's false, it means it's available, and when it becomes true, it means someone else is using it. Right? There are two main things that are used: test and set and swap. You may not use them a lot, but in real life, they're actually used in operating systems. So test and set, what that does is a process would begin by defining a variable. It says, okay, I have a variable v, right, and then it's going to say w is equal to test and set what I have for v. While w, meaning while w is true, so this is while this is true, I'll be waiting. Right, now if there are many processes, not just one, but process 1, 2, 3, 4, 5, 6, 7, and so on, someone is going to eventually set this w equal to false so that it will break, and then he can go off and do his critical section. Right. So the question is, what is happening in test and set? Right. So the test and set, the whole idea is there's going to be some shared memory location that is going to be used to hold the lock. So we're going to assume that there is some lock location. Right. And anytime you call test and set, so everyone is going to be trying to test and set with this shared variable v, which is the lock. Right. So everyone is going to be trying to set the lock. But if you go and try and set it and you don't get false. So if it returns true, you're going to be in this while loop. It returns false. So the idea is that lock would initially be false. So test and set, which is just a function, right? It's simply going to say, I'm going to copy whatever you have. This is the return value. I'm going to give you the value true, right? Which is what's happening here. So it's saying if a location is defined, so if I define my lock variable, right, and previously there was nothing in there, so let's say for this one, if I just defined it, there was nothing in there, it's false. So everyone defines it, well, it's false. That means the first time I copy, so that's the value in there, it will be false, and I'm going to return, but anyone else who asks for it, because remember when you are coming, you're going to pass in your true, right? So anyone before you come in there, um, you're going to pass in a variable, set it equal to true, and try to swap it. It's almost like a swap. So you realize it's going to take whatever is in the target, put in the return value, set whatever variable you are bringing to true, and return what's inside. So if target were initially false, that would come out. And then from then on, it will be true. So only the first person who calls this function will get the false value. After that, everyone is going to get true, true, true. And so that means by having a test and set followed by a while condition, we are going to make sure only one person gets in. Right? And after my critical section, I can set x equals to false. That means that I've now opened that lock variable. Another alternative is to do a swap where you can define your lock L. So this is the shared lock, right? And anytime someone wants the value or wants to use the lock, he's going to have his own lock. Set it equal to true. So remember, the shared lock would initially be set to false, meaning nobody has it. So if someone wants to use the lock, he's going to have to call swap. Right? So it means he's going to try and swap the two, and you check to see um, right. So that means while L is true, and so assuming L was initially false, if I set my lock to true and I call swap and I swap the content of my lock and L, that means that now the true is going to go into the L and my lock false. So I have to wait on while my lock. So that means I can now take the value, put it in mine, and use that to wait. Now, if someone else, the second person comes and calls a swap, now L contains true, so continually he'll be forced to wait. Right? So anytime he calls while, until somebody finishes off and says L equals true. Right? And the best way to write this code, sorry, is to do this. Right? That is within your while loop, keep trying to swap out to get the lock. Right? Keep trying to swap out. So eventually you will get the lock when you swap. And then you can do some critical code. Right? So there are just two things here, test and set and swap. Both of them are just functions. The idea being the first person, if the lock has never been held, calling test and set or swapping with the lock you can take the false value and use it for your action, right? So in this case, for example, I'll say while, if it's while true, it would loop forever. But if the thing becomes false for any reason, or someone had set the value, let's go to set to false, then the other people can go. Right? Now, before we finish this discussion of test and set swap, the last is sleeping and waking up. The main problem with all of these codes I've shown before is this is busy waiting. Busy waiting means there's a while loop involved. If someone else also did test and set, you can see there's also busy waiting here as well. Busy waiting means there's a lock and he keeps waiting until the lock is open, right? So what is happening commonly these days is a lot of the lock primitives in, let's say, Java would allow you to do a lock or to try and do lock but wait. So in other words, if you try to lock, you've seen some of these codes before. If you try to lock and an exception happens, or I try catch, what you try and do is, if the lock fails, you can wait. So you try to lock. If the lock succeeds, you can go off and assume you have the lock. And then when you finish, you can say lock dot unlock, or release the lock, right? But if you did not get it, you could decide to wait, right? Now, instead of just having a busy, so the idea with the waiting is if you wait, then you are asking the scheduler to put you to sleep and wake you up when it becomes available, right? So what happens is when you do an unlock, some of these do an implicit notify. In Java, you have notify. Notify means to wake up all people who are sleeping on the lock. So Java does have an explicit notify, which would actually wake up everybody who is sleeping on the lock. So instead of just having this busy waiting where you are either looping to wait to see someone has set a variable, you can actually use some concepts that some of these programming languages have, like waiting and also notifying. Notifying meaning wake up everybody who is waiting on the lock, right? So with this, we've actually discussed things. You've seen lock variables, and there are two types. Most of you don't use test and set or swap. But if you are going to be using test and set or swap, the idea, remember, is that the lock is available if it is set to false. So the idea is if someone takes the lock, he must set the lock to true. Right? So the idea of test and set and swap, with swap you take true and you try and swap it out with whatever is in the lock. If it's false, you take false. Right? And then finally we look at sleep and wake up, which a lot of you have been using implicitly without knowing it. Anytime you call a lock, if the lock is not available, you are put to sleep. And when the lock becomes available, you wake up. But as I said, Java has a function to notify and also has a function where you can just wait on the lock without even trying to see if the lock is available. You can try and sleep on it, right? So those are the main concepts that we use in programming. But as I said, test and set and swap have all now been called locks, as in locks in Java. So you will not see test and set or swap unless maybe you're doing assembly language programming. All right, thank you.